Welcome to DOS 1 Hunt. I'm Xiao Pierre Ruth for Information Week. And in this episode, we'll be discussing inductive reasoning and its place in AI and how it's deployed there. And in today's conversation, I'm going to be speaking with 4 experts who have some varying perspectives on this as we try to look at ways that inductive reasoning might be really effective as a framework within AI, but also what potential concerns or considerations might be associated with that kind of process and how it's deployed with AI and the results that it brings forth. So I'd like to first welcome our panelists. We have Nick Mattei, Professor of Computer Science at Tulane University. Bob Clougherty.
JP, good to be here.
Yes.
No, I just said hi, JP. Good to be here.
Bob Clougherty, CIO of Drew University.
Good day.
Barbara Bickham, founder and managing partner for Trailyn VC.
Thank you, JP, for having me.
Thank you. And Muddu Sudhakar, CEO of Aisera. All of you, thank you so much for being here today. So let's kind of just lay a bit of a groundwork about what inductive reasoning is and how it's currently part of artificial intelligence right now. Barbara, could you speak just like let's just level set of how inductive reasoning functions and the ways that is currently kind of woven in and put to work as part of AI.
So inductive reasoning is kind of the process of deriving general principles or conclusions around specific observations. So for example, if you are trying to ascertain if there's a person in the street versus a dog versus a bike versus a car, that is an example of inductive reasoning. And it's been in AI for many years. It's a kind of a branch under machine learning. It's how all these LLMs are created and learn. It's how image recognition is created and learns. It's how cancer data is used in order to try and fight cancer. So that's kind of a basis of what inductive reasoning is.
Gotcha. Thank you for that. Nick, is inductive reasoning something that can be really looked at as the most accurate way to find the quote unquote best answer when trying to understand data?
So the reason we do inductive reasoning is because you have a lot of data, and what you're trying to do, that the fundamental assumption that Barbara was alluding to is that if you look at enough data, you can derive generalities or some idea about what's going to happen, make predictions given the data that you have. And so the reason why it's so popular, especially now, is because we have so much data. And so any of these sort of supervised learning methodologies really rely on this. And that's what it's really for, right? It's for generalizing from lots of examples. And so in cases where you have enough data about what you're trying to generalize for and what you're trying to predict, it works really, really well. I mean, I don't know about you guys, but my, video queues and my Netflix queues and all this stuff does a really good job of kind of predicting what I want given lots and lots of data. So it's really accurate for a lot of these predictive models. And if your question is it the most precise way to reason about the future? Not always, right? And that's kind of where we run into some of these problems, because it is making a prediction that it's learned about the future, and it can be wrong in a lot of cases. And if you're more interested in getting the exact right answer, there's other methodologies in AI, reasoning from knowledge graphs, logic programming, things like that are probably better at, for sure getting you the right answer. But if you're just trying to generalize from data and make some of these high probability predictions, it's extremely effective.
Gotcha. Thank you for that. Bob, kind of following off of that question, is the idea of finding the best answer versus kind of like steering AI to look for potential, as many potential answers, the right approach, or is there some kind of middle ground that we can kind of like aim for with the kind of like framework that might be used for AI?
Yeah, I think the important place where we have to sort of pause here for a second is that, like AI, induction itself is not a product, it's a process.
Mm-hmm.
And the big thing about induction is it's not just the information and the data, but the rules that emerge from that. To go back to Barbara's example, is it a person in the street or a dog in the street? We have certain rules saying, it could be the shape, could be the size, it could be any number of issues. But in that case, we're going to continue to revise our rules because induction is the basis of how we learn, just in the same way that the machine learns. But we also mix in other methodologies. We use inference, we use deductive reasoning, and we use a tool that we need. In the same way with AI, it's all dependent upon the use case. In some use cases, yes, induction is best. In other use cases, if you want to get ideas from a generative AI in terms of how to use a large language model, that's something else. If it's reading your medical X-ray, that's a whole different area where you want to sit there with the deductive major premise and have it identify that. I mean, overall, inductive is probably the most common and the most effective, but there are use cases where that is not going to be true.
Gotcha. Thank you for that. Muddu, following off of that, are there other types of benefits with using inductive reasoning that kind of, made it a kind of right approach, I guess I want to say for the earlier days or the earlier to current days of AI in terms of being part of the framework for it?
No, I think Robert and Nicholas and Barbara kind of mentioned, right? So there's not too much to on inductive reasoning. Look, the reason people use inductive reasoning, particularly, look, I'm from right? Aisera is a startup. We like to create products. We are using the algorithms and everything. So for us, inductive reasoning is a simple way when the historical data is limited. Using a small amount of data, how can I make predictions, probabilistic prediction? It's a probabilistic inductive reasoning is the right approach to do it. So you don't need too much data to sometimes make a prediction, but as Robert mentioned, it can go wrong sometimes, right? That's why you have all the hallucinations. It's a continuous process. So, but the question is, you don't need to go, not everybody will have a sugar daddy and a sugar mommy to get $10 billion from some investors. I know Barbara may be the sugar mommy for me, but not everybody can give us that money, right? But you get the picture. So in that case, what do? When you have a limited data sets or you have a limited dollars, how do you build a product? You still have to solve the problem. So it's not about university or research. I'm here to solve today's problems and deliver it to customers, right? So that's why we look at the GPT solutions, Copilot solutions, or search solutions. So for all these things, sometimes you don't need a large language model. See, large language model may works for consumer industry. I come from the enterprise space, JP. In that, LLMs may not be the right approach. Small language model, a domain-specific SLM is anytime better than large language model. So if you put the data into Anthropic or if you put it into OpenAI, we actually can beat them hands down on accuracy because we are very domain-specific. So for that, inductive reasoning, probabilistic reasoning is much better.
Gotcha. Great. Thank you for that. All right. Thank you for each of you for lending your particular expertise on each of those questions. And the rest of the questions are going to be for all of you. If you were to each of you think, and kind of following off of that, about potential like blank spots, the gaps in inductive reasoning, what are some that like kind of really stick out to you? And also, are there ways that that just the framework of inductive reasoning might potentially be improved? I'm just still trying to look at the idea of how it can be potentially furthered, or is it the idea that there may be inherent spaces that has limits, and then the alternatives need to be looked to?
I think we need to sort of back up here from an a priori sense, because at the end of the day, as Nick had pointed out earlier, the effectiveness of the AI is really determined by the quality of the data you're putting into it. You need that single source of truth. And for many organizations, be it companies, universities, or whatever, they have to begin with a huge cleanup of all the information they have. So before we can even get there, AI is not a magic panacea if you just dump everything in there and let it go. The quality of the data and the cleanup of the data is what's most going to affect it. it's like the old Jigo rule, garbage in, garbage out. You have to make sure on the front end you get the data together, you evaluate the data. And in a lot of ways, that becomes, I won't say the blind spot, but I think with many humans, we think in the same lines as the machine in terms of induction. And just as we're prone to make mistakes, the same thing can happen within the AI. If we don't have correct data, we make bad decisions. If the AI doesn't get trained appropriately with the right data, it will make bad decisions.
Yeah. And I think just picking up on that, Bob, for a second, like it's more than just whether or not the data is good. It's about whether or not the data is representative of the thing you're trying to predict. Mm-hmm. So a lot of times, if you're using data that's convenient and you say, oh, this is about what I want, like these algorithms are very good at finding patterns in the data, even if it's patterns that you maybe don't want it to find. There was a great example at a vision conference I was at recently that was looking at recognizing patterns in electrocardiograms for heart patients. Well, it turns out they were using these things are very sensitive machines, and there was one model they used for everyone who had the heart condition, and one model of the ECG that they used for everyone who didn't have the heart condition. And the sort of inductive reasoning ML algorithms were able to perfectly identify the two. But when you dive into it, what the difference was is that there was other slight differences in the machine that they had used between the two treatments. And so the algorithms are good enough to pick up on these slight differences in data. And it's something that we've really got to pay attention to when you're looking to deploy things based on inductive reasoning and machine learning, is that that the data really represents what you're trying to predict. Because if it doesn't, it's the process can possibly pick up on these extraneous variables, these things, or it's going to try to predict things that maybe you don't want it to. And that's where I think a lot of the mismatch, like Bob and Muddu was saying, is between what you're trying to do and with the data that you have. You got to really make sure those are aligned, because if they're not, this whole process really isn't going to work for you.
Let me give you a different view, guys, Nicholas and Robert. Look, the way in which we see from the enterprise world is people don't have time to go clean up the data and then do it. By the time you're done, that person may not be in the job. Like an average C-level person is in the job for 18 months to 2 years. So this concept that you want to clean up your garage, it's a springtime and then I'll deploy AI, that's outdated. Right now, what you want is deploy your AI next to your data. Your data could be garbage, your results will be garbage. That's as long as you're aware of it. Like if I'm going to send my kid to a college, but I know my kid is not good in taking 7th grade, then I know what I'm up to, right? It's the same analogy. You don't need to know. It should be ongoing basis. There's enough things have gone through prompt engineering and RAG, etc. Instead of you cleaning up the data, once you get the response, it's better to clean it up. Or second thing is, don't look at one type of data. Like when we walk in, the data is not in SharePoint or Dropbox or ServiceNow, Salesforce, etc. It's actually in people's logs, Teams logs, Slack logs, or people could be in call center transcripts. So as long as you have a diverse data, let's say if you want to know how to resolve your payroll issue, your 401k contribution, you may have data in multiple repositories, including Workday, etc. So able to disambiguate is the burden of the algorithm than trying to say, let me clean up the data, etc. You're right. At some point, there may be a data needs to be cleaned up, but I don't recommend to customers saying that let's hire an army corps of engineers and clean up data for 10 years and then deploy AI. We may not even exist in 10 years. So idea is to shoot first. This is an agility. AI is changing so much. To Jensen's point, the CEO of NVIDIA, this is like a 100-mile train running. So you get on the train first. You don't sit outside the train and try to dig up. That's never going to happen. Train is going to leave your station.